Good morning all of you. Welcome back to course Database Management System. So our today's topic of video is query optimization techniques. So we already come to know what is query optimization. So in the word query optimization, the word is optimizer. So what optimizer means what? Optimization means what? We need to minimize the number of resources required to execute a particular query. So that optimization we can do in terms of time as well as number of resources being used. So here we are going to discuss what are the techniques that can be used for optimization. So we know that what is optimization. If we see the formal definition, it's a process of selecting most efficient query plan out of the many plan. Because I told you, in order to execute a single query, multiple number of ways are there. So you need to evaluate which way is more efficient and which way is using less number of resources. This is what a important thing to know. As I told you that a single numerical can be solved by using different algorithm. One numerical can be solved by using different techniques. Maybe the case that technique 1 is taking 5 minutes, technique 2 is going to take a 10 minutes. So in that case, what will happen, you will choose a technique which takes less amount of time. So in the same way, in case of a database, whenever you are writing your SQL query, that is in the high level language, we need to optimize it. So optimization can be takes place either at user level or it is takes place at a system level. But every time you cannot expect from the user to optimize the query or to write a query in the optimized way. So in that case, optimizer component of your database comes into existence and it will generate a number of query evaluation plan, and out of this it will select one efficient query plan which takes less number of resources. So here we need to discuss what are the techniques that can be used for query optimization. So there are two optimization techniques are there in case of a database query optimization technique. One is a cost based optimization and second one is a heuristic based optimization. So the cost of query is totally depend on the statistics. Statistics means how many number of records you have fetched, how many tables you are going to use, how many time does it required, so how many different values are there for single attribute. So these are the various parameters are there based on which you need to evaluate the cost of a query, and the cost of the query evaluated based on number of row, and ultimately what is cost? Cost is nothing but a time. How much time does it take to execute a particular query? Because we want to reduce the amount of time required to retrieve the data. Why we are writing query? In order to retrieve the data from the database. So we expect that once we write a query and fire it on a database, within a quick second we should get the output. So this is what the ultimate aim of writing the optimized query. So first technique is a cost based optimization. So cost based optimizer, it generates a range of query plan, and from that plan it will choose one with a least cost. So let's see the example so that you will understand. So here, suppose the problem statement is that I need to find such a customer whose city is Nagpur. Okay, I want to find such a customer whose city is Nagpur, whose branch city is Nagpur. So here I have total 3 tables. One is a branch table, account table and the depositor table. These 3 tables are there. So from this I need to find customer name. So here there are 2 possible ways are there to evaluate this query. This is initial expression. Here you can see, first of all I will join account table with a depositor table, then I will join with the branch table. So this is what a query, and I told you that query optimization takes place at relational algebra level. Okay, it takes place at a relational algebra level. So what I have done, I have written 2 relational algebra query. In relational algebra query 1, you can see, first of all I am going to perform join operation between account depositor, then with the branch, and then I am applying the condition that city should be Nagpur and finding the customer name. And this is the alternate way of evaluating this query, where first of all parallelly we are doing 2 operations at the same time. First of all we are performing selection operation over here, and at the same time we are performing join operation, and then after that we perform join operation, and finally we are going to perform projection operation. So this is a query 1, this is query 2. so this is a diagrammatic representation, or you can say this is a query evaluation plan. This is what a relational algebra query, and this is what a query evaluation plan. So in this case, can you determine whose cost is less and why? The cost of query 2 is less as compared to query 1. Why? The reason is very simple. In this case, first of all, you are performing join based on account and depositor table, and we know that join operation involves combining every row of first table with every other row of another table. So we are performing join operation. So here some amount of rows can be generated. Again you are performing join operation, and then you are performing selection operation. But in this case, this is not the case. Here first of all you are performing selection operation, and you are applying condition on the branch table. So you are just getting the rows whose city is only Nagpur. Just imagine a situation that 1000 rows are present in the branch table and only 100 rows having city Nagpur. So in that case, what will happen? That 900 rows get eradicated. But in this case, this thing is not there. We are considering all 1000 rows. So ultimately it takes a lot of time. So that's why I say that the cost of query 2 is less as compared to cost of query 1. So what exactly we are doing in case of cost based optimization? First of all, we need to generate logically equivalent expression using equivalence rule. We already discussed various equivalence rule. 12 equivalence rule we have discussed, where we have seen one operation can be replaced by another. As I told you that one query can be written in a multiple ways. Multiple operators are available, so you can use different operator for that. So in step 1, in case of cost based optimization, you have to generate logically equivalent expression using equivalence rules. Then you have to annotate the resultant expression. So here you can see I have generated two equivalent expression. This is expression 1 and this is expression 2 by using equivalence rule. Then in step 2, what I need to do, annotate the resultant expression. This is what annotation I have done, and finally choose the cheapest plan based on the estimated cost. So here the cost of query 2 is less as compared to query 1 because number of rows are less. As I told you that cost is totally depend on number of rows present in the table, number of attributes is accessing, what are the different rows are there, how many tables you are referring. So these are the various parameters, but what is the ultimate parameter? Is time. How much time does it takes to evaluate this query? So for cost based optimization, I'm going to select query plan 2. I miss what? Your optimizer will select obviously plan number 2. Why? Because its cost is less. So this is what a cost based optimization. And the second type of technique is heuristic based optimization, which works based on the heuristic. Heuristic means what? Rule. Cost based optimization is based on the cost of a query, and heuristic based optimization is a rule based optimization. There are certain rules are there that we need to follow while optimizing the query. Just like that, while evaluating the expression where we have a number of arithmetic operators are there, so generally we are using BODMAS rule. Similarly here you can see in case of heuristic based optimization, there are certain rules are given which we are going to use to optimize the query. So that we are going to discuss in detail. So first of all, we just understand cost based optimization, and we need to discuss one algorithm that can be used to estimate the cost in a larger expression. Suppose this is what a simple query that we have seen. Okay, this is what a simple query, but very complex queries are there. So in that case you need to evaluate its cost. So this is what one algorithm is given based on the concept of dynamic programming. So we try to understand this cost based optimization algorithm which is given in your book. Okay, so here we have created one procedure find best plan of S. S is a variable which stores the relation. Okay, so if base plan of S dot cost is not equals to infinity, when we say that particular plan is the best when its cost is not infinity. Suppose the particular plan is having cost infinity, so obviously that cost is not better. So initially we are checking that whatever the plan that we are going to use to evaluate a particular query, whether its cost is not equals to infinity or not. Means we are checking the equality infinity condition. So best plan S already computed, return the best S. So here if S contain only one relation, S means what? S is any variable which stores the number of relation. Suppose only one relation is there, then there is no issue. So in that case you can set best plan of S dot plan and best plan of S dot cost based on the best way of accessing the S. When in particular query only one relation is there, at that time there is no problem. Okay, means main issue is what? When number of tables are involved in a particular query, then your query get complex, and at that time there is a possibility of optimization. If you are writing a simple query and you are expecting that optimization takes place in that, so this is not possible. Sometimes it is possible, but mostly optimization is required when you are writing a complex query, and in complex queries we are not accessing only one table, but we are accessing a multiple table. So in this case we are considering all the cases. So here what we are saying, suppose only one relation is there, so in that case you can find a plan and its cost. Then else for each non-empty subset of S1 of S such that S1 is not equals to S. Just imagine a situation that S variable contains of three relation, S1 tables are there. So in that case what you will do, first of all P1 equals to find best plan of S. So in this case suppose in your query, so total 4 join operations are there, J1, J2, J3, J4. So in that case what you will do, you just divide this into two parts. First J1 join with J2 and second join J2 with J3 with J4. So in first case what we are doing, P1 equals to find the best plan S1. That means we need to find the best plan of joining J1 with J2, and that we are going to store in the P1. Then in P2 what we are doing, find the best plan for S minus S1, because in our S variable total how many tables are there? Total 4 tables are there. Suppose table T1, T2, T3 and T4. So in order to join table T1 and T2, what I am doing? I am doing P1. P1 equals to find the best plan of S1. So here I am joining table 1 with table 2. So it involves some kind of cost. Similarly I am going to calculate the cost required to join table T3 with T4. And finally we need to find best algorithm for joining the result of P1 and P2, because individually we have calculated the join operation of table T1 with T2 and T3 with T4. So that we are storing in the P1 and P2, but finally we need to combine the both the results, because ultimately in a final query we need to get join for all the 4 tables. So here we are using best algorithm for joining the results of P1 and P2. So here cost equals to P1.cost plus P2.cost plus cost of A. So how to calculate total cost? So in this case P1.cost, that means in order to find what is the best way to join S1, there's some cost is involved, here some cost is involved, and finally cost is also involved to combine these two, so that we will get the final cost. And if this cost is less than base plan of S dot cost, it is just like that. Suppose you know the logic that you are using to find the smallest number in array. Suppose I have been given a set of 10 numbers and I have been asked to find smallest number. So in that case initially what I am doing, I am considering first number as a small number, and then I am comparing next number with this. Suppose the next number is smaller than the previous one, then I am going to change the value of smallest number. So same thing is there. Initially we are checking best plan as dot means if the cost of best plan dot cost is less, then we can assign new cost as a best cost. Best plan of S dot cost equals to cost. That means suppose this cost is less as compared to the previous cost, then we can assign it, and we just find it best plan of S dot plan equals to execute P1. This is for plan P1, this for plan P2, and joining the result for P1 and P2. So in this way it will return the best plan for S. So this is what a dynamic programming algorithm is given in case of a cost based optimization, which help us to get to know which one is a better way for joining the tables. Okay. So this is what a cost based optimization. So I hope you understand the cost based optimization techniques. So these three major steps are there: generate logical equivalent expression, annotate the resultant expression, and choose the cheapest plan. So these are the three steps involved in a cost based optimization. Then we talk about heuristic based optimization. So what is a heuristic? Heuristic based what? Rules. So heuristic based optimization is also called as a rule based optimization. So system may use some set of rules to reduce the number of choices that must be made in a cost based fashion. So in case of a cost based optimization, what we are doing, we are trying to reduce the cost. We need to try to reduce the cost. We need to find the efficient way of doing this, but in that case we are using some set of heuristic that I will apply this set of rules so that query can be optimized. So heuristic optimization transform the query tree by using set of rules. See, one point that I want to tell you: cost based optimization as well as heuristic based optimization both will use equivalence rule. Okay, so what are the rules given in case of a heuristic based optimization? Very first rule: perform selection as early as possible. So this is what a first rule. Okay, then second, perform projection early. This is the second rule. Third, perform most restrictive selection and join operation before other similar operation. And the fourth step is some system use only heuristic, other will combine heuristic with cost based optimization. See, nowadays most of the databases making use of a combination of both cost based optimization as well as heuristic based optimizer. Okay, suppose you talk about Oracle database. So maybe you have a question in your mind that what type of optimization technique is used by your Oracle database. So in that case the answer is very simple. Nowadays most of the databases is going to use the combination of both cost based as well as heuristic based. Initially cost based optimization is used, heuristic based optimization were used, but nowadays most of the databases are using the combination of both the techniques, cost based as well as the heuristic based. So here what I'm explaining what are the rules that you need to consider in a heuristic based optimization. So I just told you rules. Now let's demonstrate with the example. Suppose this is a simple query. I need to write a SQL query to retrieve the students whose age is 20 and they are studying subject DBMS. And in that case, suppose there are two tables are there. One is a student table where personal details of the student is being stored, and second one is a class table where student studying which subject, that information is stored. So in that case, what I need to retrieve? I need to retrieve the details of student whose age is 20 and who's studying subject DBMS. So in that case, age of the student is not present in the class table, whereas the subject details is not present in the student table. So I need to use two tables. One is a student table and second one is a class table. From the student table I will get the age of the student, and from the class table I will get the subject name in which particular student is studying. And what I need to retrieve? I need to retrieve the name. So name is present only in the student table, but it is not present in the class table. So how to write a query? This is the first way of writing query. Select S name from student S, comma class C. So here you can see we are going to perform equi-join. We already discussed about different types of join. So here we are going to perform equi-join because here we are checking the equality condition where S dot roll number equals to C dot roll number, because student table, what is a primary key in case of student table? Roll number is a primary key, whereas in the class table class ID is a primary key. But in this case roll number act as a foreign key in the class table. So here we are using equi-join. So we are checking the equality condition that S dot roll number equals to C dot roll number and age equals to 18 and subject equals to DBMS. So if you remember what is a condition that we are going to use while performing equi-join. So in case of equi-join we require at least one common attribute should be present between the two tables. So what is the common attribute? Roll number is an attribute which is common in the student table as well as in the class table. So here this is a join condition that we are writing over here. And this is the first way of writing query. Now this is what a second way, because in heuristic based optimization what is being asked? perform selection as early as possible. Here what we are doing, we are not performing directly selection first, but here performing join operation first. Okay, so now this is another way of writing query. Select sname. Sname is nothing but the student name. From select star from student where age equals to 18. This is what alias. S is a alias for student and C is a alias for class. So here what we have done, we have performed selection operation first, because we know that selection operation help us to reduce the number of rows, whereas projection operation help us to reduce the number of columns present in the table. So according to heuristic based optimization, first rule is there, perform selection as early as possible. So here for first of all we need to perform join operation, but here we are not performing selection operation first, but here we are first performing join operation. But in this case, first of all we are going to perform selection operation, and selection operation always involves condition. So here first condition is that age should be 18. Sorry, here by mistake I have written, actually age should be 20. Okay, so it's just type mistake, don't worry. Then select star from class where a subject equals to DBMS. So again we are performing selection operation on the class table, and we are getting some rows, and then we are performing then we are checking the equality condition over here. Okay, so what do you think, which one is the efficient way, whether this query is efficient or this query is efficient? So what is your answer? So answer is second one. Why is it so? Because in this case if you see, first of all I perform selection operation, so here I am getting only the data of those students whose age is 20, but I just remove all the rows where age is not 20. That rows are eradicated, but here this thing is not there. Here I am going to consider each and every row whether age is 20 or it may not be, and also here I am just eradicating the rest of other subject because I am interested only in subject DBMS. Okay, so here you consider all the subject, it may be DBMS, DA, and you consider all the subject, but here I am considering only DBMS subject. So what is the use of this? By using this, number of rows are reduced. If you reduce the number of rows, obviously then performing the join operation will take less amount of time, less number of intermediate result is being generated. So that's why this is a more optimized query as compared to this. And here what we have used the heuristics. And what heuristic optimization means, what you need to use set of rules, and first rule is perform selection as early as possible, and we have seen that if you perform selection operation as early as possible, then your query can be optimized. So here you take less amount of time as compared to this, because we know that in case of join operation we are performing two things, one is a Cartesian product and second one is a selection operation. And in Cartesian product we are joining every row of first table with every row of other table. So in this case more number of rows we have to combine, but in this case we need to consider only few rows, because first of all we apply selection operation, so it helps us to reduce the number of rows. So this is what an example that you can use in case of heuristic based optimization. Now I hope you understand what are the how heuristic based optimization works, and I think I just clear that nowadays most of the databases is going to make use of optimizer, which is a combination of both cost based as well as the heuristic based. So lastly we just discussed what are the steps involved in heuristic based optimization. What are the different steps are there? Though we have seen that it is a rule based optimization where we are going to use set of rules, but there are some steps are given in case of heuristic based optimization. So what are the steps? Step 1, you have to deconstruct the conjunctive selection into a sequence of single selection operation. What is the meaning of this? So this is equivalence rule 1. We already discussed equivalence rule 1. So we'll see here what is rule 1. This is your rule 1. Conjunctive selection, you have to perform conjunctive selection can be deconstructed into sequence of individual selections. So this one is there. Instead of performing it in a combinedly, what we do, we just split it into and perform it in a individual way. This is what a step 1 in heuristic based optimization. Deconstruct the conjunctive selection into sequence of single selection operation. Then second step, move selection operation down the query tree for earliest possible execution. This is also we have seen over here. Okay, here what we have done, we have just move the selection operation down the tree. Why is it so? Because this query evaluation plan is evaluated in the bottom up manner, not in a top down fashion. So here you can see selection operation is performed here, but here selection operation performed first. So this is the second step in heuristic based optimization. Then the next one, execute first those selection and join operation that will produce smallest relation. Just we have seen that perform selection operation which perform or which generates less number of rows, and this is based on equivalence rule 6. So again we'll see whether what rule 6 says. This is 6 is rule number 6, natural join operation are associative. So here you can see, so thing is very simple. You need to perform that selection and join operation that will produce the smallest relation, because suppose it produce the less number of rows, then its cost is optimized. Then replace the Cartesian product operation that are followed by selection condition by join operation. We already know in case of relational algebra, wherever you find a Cartesian product and selection operation, you can replace it by join operation. And next one is deconstruct and move as far down the tree as possible list of projection operation. This is also possible that you need to just move projection operation down the tree as that of selection operation, because I told you that selection operation help us to reduce the number of rows, whereas projection operation help us to reduce the number of columns present in the table. Just imagine a situation in your table 100 columns are there and you are interested only in column 1. So why need to consider all the 100 columns? So in that case, what you need to do, you need to perform projection operation first, so that you just eradicate or eliminate 99 columns and you just focus on one column. So that's why this step is given, deconstruct and move as far down the tree as possible list of projection. These are the various steps that may vary from scenario to scenario. It is not a case that every time this strategy will work. You need to apply it, you need to think about it, you need to apply your logic that in that situation what I need to do, whether I need to perform selection operation first or whether I need to perform projection operation first. You need to apply your logic. And finally, final step, identify those subtree whose operation can be pipelined and execute them using pipelining. We already discussed two techniques. One is a materialization and second one is a pipelining. So we have seen pipelining help us to improve the performance of a query. How? Because in the materialization we need to generate intermediate result, and creating intermediate result, storing it in a secondary memory, again retrieving it in a main memory, it takes a lot of time. So instead of this, in case of pipelining, directly we are providing the output of one operation to next operation directly. So these are the steps that you need to perform in a heuristic based optimization. So I hope you understand what are the techniques given for query optimization. So there are two techniques are there. One is a cost based optimization and second one is a heuristic based optimization. And nowadays most of the databases are using optimizer, which is a combination of both cost based and heuristic based. Thank you.